GMAT all day.
On the GMAT, you need to know how to both factor expressions and equations, as well as reverse factor or distribute, sometimes called foiling equations. But factoring in particular is very useful and very valuable. And I'll explain why. Because if you have an expression, something like 3x plus 6y, and you can factor out a 3 here. So now this becomes 3 times x plus 2y. Well, how does this relate to divisibility? Because look at what you have done here. You have taken this addition expression and you have turned it into a multiplication expression. You now have 3 times this expression here. And so I can now use, once I have it as a product of 2 terms, I can use my divisibility rules to tell me stuff about this expression. So if I have some question, for example, and it tells me x and y are integers, well, now I know that this expression can be expressed as 3 times some integer. So this has to be a multiple of 3. And so factoring, I think, is very useful because you can convert an addition or subtraction problem into a multiplication one, but you can then use your divisibility rules to infer useful properties from your expressions. So how would you actually use this on the GMAT? This question says, if r, s, and t are integers such that t is equal to 147r minus 96s, is t divisible by 12? So is t divisible by 12? Is t a multiple of 12? Is 12 a factor of t? Is t over 12 equal to an integer? Does t contain a 6 and a 2? Does t contain a 4 and a 3? Or if you want to break 12 up into its prime factors, does t contain a 2, 2 2s, and a 3? And so if we want to know t is equal to 147r minus 96s. So if we want to see what else this might be telling us, we might try and factor this equation here. Then the question becomes, can we factor this? So we can use our divisibility rules to see that 9 plus 6 is 15, 1 plus 4 plus 7 is 12. So these should each be divisible by 3. Therefore, we should be able to factor out a 3. And the question becomes, so what is 147 divided by 3? So 3 times 49r minus 3 times 32 is 96. So t is equal to 3 times 49r minus 32s. This is a case where keeping in mind, taking note of this over here, that r, s, and t must be integers is actually helpful, because that means 49r minus 32s must also be an integer. So from here, we know t is a multiple of 3. Now what that does is that actually makes this 3 appear irrelevant, because we know that no matter what we are going to have it, we're just looking for our 2 2s. And so we can rephrase our entire question before moving on to the statements as just, is 49r minus 32s a multiple of 4? Statement 1 says r is a multiple of 4. So how can we incorporate this statement into our question? Well, one thing you can do is you can say, if r is a multiple of 4, if you want to write that as an equation, you can just say that means r is equal to 4, and I'll say y, where y is just some integer multiplier. So r is equal to 4y, and then I don't know what y is, but it's just some positive integer. If I were to write that here, I could write 49r minus 32s as 49 times 4y minus 32s. So what can I do here? So you can take out a 4 now from each of your 2 terms, because 32 contains a 4 and our 4y also contains a 4. So I have 4 times 49y minus 8s. So if we just keep in mind that y is just some integer multiplier, I don't know what y is or what s is still, but I know I can express 49r minus 32s as 4 times 49y minus 8s. So that's just 4 times some integer. This is telling me that 49r minus 32s must be a multiple of 4. It can be written as 4 times some integer. So this statement here is actually sufficient. because I already have my 3 to start. And then this is telling me that I have my 4 from over here. Statement 2 says S is a multiple of 4. So statement 1 says R is a multiple of 4. Statement 2 says S is a multiple of 4. Don't assume that if R being a multiple of 4 is sufficient, that S being a multiple of 4 must also be sufficient. I don't think that logic is necessarily valid, although it might not be bad if you have 5 seconds left. Have to guess. Let's see if it's actually true, though. We're trying to figure out if 49R minus 32S is a multiple of 4. And we know that S, I won't use Y this time, S can be written as 4Z, let's say. So now we want to know is 49R minus 32 times 4Z multiple of 4. So can I pull out anything from here? I don't think so, because this 49 is just made up of a bunch of 7s, and I don't have any 7s over here. All I did is I already had a 4 here from the 32, and it looks like I just added an additional 1, which means nothing new was added, shared between my two terms. So I don't think I can pull anything out here, and that means that whether or not 49R minus 32S is a multiple of 4, it depends on the values for S and Z, which can be almost anything. So this is going to be insufficient. In other words, in order for us to know that 49R minus 32S, or 32 times 4Z, is a multiple of 4, we need to know that our S contains a 4. Or sorry, our R contains a 4. The tail on my R here, so it makes it look like an S. So 49R minus 32 times 4Z will be a multiple of 4, because I'll be able to pull out a 4 if I know my R contains 1. But I don't know anything really about R, so this is insufficient. A is the answer.